Okay, it started recording automatically. Weird. Anyways, so I am reading pages. So I am reading Machine Learning by Tom and Mitchell. I'm on chapter 3, the bottom of page 55, going all the way to, let's say, 59. It introduces some really important topics. I'm going to use the simple example. How much information is in a dice roll? Today we'll understand what a bit really means, how entropy measures uncertainty, and how information gain helps machines learn smarter. So a bit of information is the answer to a yes or no question, to a binary question. And it's simple if you assume all outcomes are equally likely. It's simple if you only have two outcomes. For instance, a coin flip, heads or tails. You just have to ask, is it heads or tails? That's one bit of information. And that's the bit of information is the question you need to ask. But what if you have a dice roll and you're trying to find out, somebody's rolled a dice, they don't tell you what it is, but you have to guess. How many questions on average would you have to ask in order to know exactly what that dice roll was? So for example, you could split it like, you could say, okay, is the dice roll even or odd, right? That's one question. Then, depending on what it is, maybe it's a 4, you ask, okay, is it greater than or equal to 4? If the answer is yes, then you know it's 6, right? So that would be 2 questions. But if the answer is no, then you have to pose another question. Now it's 2 questions already, then you have to pose the third question. And so the entropy measures how many bits of information you need in order to understand what that dice roll was. And the answer to a dice roll is 2.585 bits of information, or entropy. And entropy measures how uncertain a variable is. They have a formula for it. It's basically log base 2 multiplied by the probability of the specific outcome you're looking at. You add up all those outcomes, and then it's going to end up being negative. So you need another negative because it's a upside down parabola. So yeah, there's that. What else? So yeah, entropy measures the impurity of your sample. How impure is your sample? And by purity, it means, okay, how many times do we have to ask questions on average to figure out what an unknown instance is? So yeah, and then information gain is in machine learning is basically the entropy before whatever feature, whatever question you pose, and the entropy after. So the difference between the two. So for example, in the dice roll example, if you if you pose the question, is it even or odd, right? I assume, let's see, what's the entropy after? Because if the entropy before is 2.585, and then you pose that first question, I believe the entropy will be 1.585, but I don't know that for certain. So what's the entropy in the dice example after you pose the even or odd question? Let's hope I'm right. Yeah, the original entropy was 2.585. Yeah, so it's 1.585 after, right? Because you posed one question that split it into two equal groups. So what you have left is log base 2 of 3. And the information gained was 1 bit. Like it was one question. So, and you can say that with certainty because that particular question always splits the sample size in half. So yeah, back to my point. The information gain is how much information, the entropy difference after you pose that question. So before is 2.585, after it's 1.585. So the information gain is 1. Right? Yeah, 1 bit. So there's that. So that's information gain. I'm about to run out of time here. So bits are information from yes or no answers. Entropy is how uncertain a situation is. And information gain is how much that uncertainty drops after learning something. Thanks for watching the video. Hopefully it helps you. Helped me a lot. And I'll see you in the next one.